Okay, welcome everyone. This is joint work with Jens Witkowski, who is here, Barbara Mellers and Phil Tetlock at Wharton.
Stand between these two bits
okay.
of tape that came.
All right, that's right. Okay. So this is an empirical paper, so this is a change of pace from some of the other papers that follow and precede this one. But I hope that at the very least, even if most of what you do is theory, it will be at least useful food for thought for you. So what we're looking for is crowdsourcing. Crowdsourced predictions, or more specifically, crowdsourcing probability forecast. And what we want to do is we want to assess the active ingredients of what makes crowd forecasts accurate. And practically, yeah, we want to boost accuracy, but also a secondary objective is to reduce information leakage in a crowd prediction. So what do we mean by that? Well, for a long time, Google was running a prediction market. And the chief economist of Google, Havarian, when asked by Tyler Cowen why they had to shut it down, what he said is, well, the things that we really want to get the probability assessment on are things that are so sensitive that we thought we would violate the SEC rules on insider knowledge. So if they have something that's sensitive about the company, like when they will launch the next product, that may materially affect the stock value, and someone goes on the internal prediction market and makes a big move, then everybody on that prediction market knows because the price has moved, and that may be considered insider knowledge, and so Google may get into trouble for creating insider knowledge. So we want forecasting systems that are both produce accurate forecasts, but also don't produce information leakage that might get you in trouble, either with the SEC or just share more information that you didn't want to share as the information aggregator. So we have two ways of doing it. One is to look at the elicitation and aggregation structure, mostly the elicitation, how much feedback the system or software provides. So we're going to be looking at two different systems, prediction polls, where you ask experts about their probabilities, and then you give them a proper scoring feedback, and prediction markets, where they make bets, and the bets produce a price. So and then there's the parts that you can put into software, the scoring rules, the interface, and then there's the forecasters. Who do you choose to be in your crowd? So you can think of it as the software part of the system and the wetware, the brains that you're asking to do work for you. So there are two different research streams focused on systems versus forecasters. I'll just highlight some. So we had a paper back in 2017 comparing prediction markets and prediction polls. As I mentioned, in prediction markets, you place directional bet. I think this event is more likely than this, so I'm going to buy a share and increase the price. Versus in prediction polls, where you make probability forecasts, the scoring in markets is based on your earnings. If you make good bets, you earn money. If you make bad bets, you lose money. In prediction polls, it's basically a proper scoring rule, like a Breyer score or logarithmic score. The aggregation in markets is behavioral. It's through the market price. And in prediction polls, it's statistical. You take some kind of a, let's say, extremized mean or some different kinds of aggregate. And what we have found in prediction polls is that what you want is the optimal sample is not necessarily representative of the population. You want skilled forecasters. Maybe not so many. You don't need necessarily a large crowd, but you need a skilled crowd. The question is, does that also work in prediction markets? Can you get away with having a few active, skilled traders in a prediction market setting and still produce highly accurate results? And this builds on work by Sharad Goel, which he presented in 2010 at ACMEC, as well as Jason Dana et al. The other part is the forecasters, the wetware, right? So the project that I was part of, Good Judgment Project, produced the finding about the super forecasters, who are these really accurate, consistently accurate forecasters. You can find them by just giving them many questions, scoring them, and then taking the top 2% each year and placing them to work together. So far, what we knew based on that and what Phil Tetlock summarized in his book Super Forecasting is that when you do that, when you get these folks together and you put them in teams and team polls, they do really well. They do better than almost any other method. And what I'll update you on is the last experiments that we ran in the last year of this project, which pitted elite super forecasters in prediction markets and polls. A lot of work, including some work by Dan Goldstein that has been presented here in prior years, focuses on this bit, like which forecasters do you want, how many, and how do you select them. So the Good Judgment Project was one of the research teams of the ACE, the IARPA ACE prediction tournament. It lasted for 4 years or 4 seasons. We were the only surviving team after 2 years of the tournament because our team produced more accurate forecasts than the other teams. Each season had about over 100 forecasting questions. We had many different conditions, and I'll be talking about a couple of selected conditions out of that. We had hundreds of forecasters in each conditions and over 1 million forecasts over the 4 years. So my focus here will be on 3 pieces of the crowd forecasting puzzle. One is market structure or market architecture. If you have a prediction market and you want to maximize accuracy, do you run a continuous double auction market or an LMSR, a logarithmic market scoring rule market? It will turn out, to preview the results, that LMSR markets work better with our parameters. And then so we're going to look at LMSR markets and team polls with either small groups of elite forecasters or larger group of non-elite forecasters. And then it will turn out that the elite forecasters are doing quite well in both systems. So then we're going to turn out into looking at, okay, so which system between prediction markets and prediction polls gives you more precise and reliable signal about who is good at prediction? So how do you qualify or identify the elite forecasters? You may be familiar with the difference between continuous double auction and logarithmic market scoring rule markets. Both of them elicit directional bets. In CDAs, the order execution is immediate if there's another order on the other side, or it stays on an order book. In an LMSR, it is immediate. You always have a trade counterparty in the LMSR market because it's the automated market maker. The weakness in implementation is that when CDA markets are thin, they may produce less accurate forecasts. And in market scoring rule markets, the market maker might have a loss, which makes LMSR market, the most frequent applications of them are with play money, because if the market maker loses play money, that's not a big deal. On the other hand, CDA markets, many of them work with real money and are large and public. So you may recognize Predicted, Cauchy, Hypermind, and others that are running this. Microsoft Research has done a lot of work on LMSR markets, and Cultivate currently has a commercial platform that we used in this example. So when Robin Hanson developed market scoring rules, he thought that market scoring rules can combine the best of simple inform market, that he called them, or continuous double auction market. So when there are many traders for every question, you have enough liquidity, and LMSR and CDA markets would do really well. But when there's very few traders per question, or very, very many estimates that a trader needs to make, then scoring rules are better because you get into the thin market problem. And so we're going to look into that expectation as well by comparing CDA versus LMSR markets at different kinds of settings. So the first question about those two types of markets was based on season 3 of the Good Judgment Project. We have about almost 150 questions. We assigned us 750 forecasters randomly to one or the other. And the rewards were basically play money and reputation. And the top 2 forecasters, as in every condition, became super forecasters and got more reputation and a free trip to meet other super forecasters. We're looking at system scoring in terms of the Brier score. So we, as a research team, are scored based on quadratic Brier scoring rule. The way the LMSR market works is that traders can bet, let's say, on a binary question on yes or no. The more they buy yes shares, the price goes up. The more they buy no shares, the price goes down. So and the price is determined the balance between quantities bought on yes or no shares, and it also on the liquidity parameter B. So in our condition, we had a parameter B, liquidity parameter of 250, which means that if I go into a market that starts at 50-50 and I purchase 100 shares, I will be moving the price continuously. The final price after I bought all the shares will be about $60 per share, and the average price that I bought is about 55. Dave Pennock has done a lot of work in translating the original logic of market scoring rules that Robin Hanson developed into a market logic that then Cultivate and others have implemented. So the main result is that the LMSR market significantly outperformed the CDA market, and that result was especially strong on questions where we had few unique traders per question. So on markets, in questions where the CDA market attracted fewer traders, there was significant underperformance. On the other hand, on markets where both systems had, let's say, more than 100 traders, the accuracy was approximately the same. So what we're learning is that, yes, Robin Hanson's expectation that CDA will encounter tin market problems are consistent with our experimental results. So now, after we learned this about the LMSR market, in the next season, we put the LMSR market to test against team prediction polls, which had proven also very accurate in previous years of the tournament. This was the last season, and we had 136 questions. Again, we were looking at Brier scores for aggregate forecast. In polls, also individuals were scored based on Brier score, slightly different imputation rules. And we're looking at different aggregation structure. One was extra mice weighted mean aggregation, and the other one was ULINOP, or unweighted linear opinion pool. We just basically take the simple mean of everyone who provides a forecast without any weighting or extremization. So it was a 2x2 structure, so we had sub-elite forecasters, larger crowds of about 300 forecasters, versus the elite groups that were approximately 2.5 times 120 to 140 forecasters. They were either in team prediction polls, so teams of about 12 to 15 individuals, or in a supermarket, which was the LMSR market that runs with the pre-selected traders. So the sub-elite forecasters were randomly assigned. They came into the experiment, and we randomly assigned them to either a team prediction poll, MSR market, or other conditions. The elite forecasters were partly self-selected, so we randomly assigned the new ones. But the returning super forecasters were very important to us, so we gave them a choice. And most of them had already been in prediction polls. And most of them chose to remain in prediction polls. So that's something that we need to keep in mind. So the results were, so we're looking at aggregate Brier score where lower is better. And what we see is that the biggest difference was between elite crowds, which did better, and sub-elite crowds, which did worse. The difference among markets, LMSR markets, and team polls were smaller. And also our aggregation, the more sophisticated full aggregation versus the simple unweighted linear opinion pool did not make a difference. So it mattered for our overall accuracy who was in the sample. Small elite crowds did better than larger sub-elite crowds, and that was true in both the poll and the market setting. So the differences between the different crowds were significant, while the difference between the different systems were not. One thing that we found was that the LMSR market produced underconfident forecasts, so we could have extremized the market prices towards 0 and 1 and done a little bit better. So this was for the supermarket, but it also holds across years for our larger market as well. It makes us think that probably the liquidity parameters were set a bit too high, but after we have the prices, we could have improved accuracy slightly by extremization, even of the market prices. Our choice for the top 2 as a cutoff of the top 2% of forecasters to make them super forecasters was not anything magic. It was just based on our organization of the tournament. We could have, in fact, picked much fewer forecasters. So this is a subsetting analysis where instead of 10 super teams, we have only 2. And even 2 teams of approximately 25 to 30 forecasters would have done significantly better than the crowd of 300, what we call sub-elite individuals. So once you have identified, reliably identified top forecasters, you really don't need too many of them. You can do well with approximately 30 forecasters for over 130 questions. And the last question is, which system is better at spotting or finding elite forecasters? We had 2 different systems that produced forecasters by giving them earnings or Brier scores in the top 2%. And in season 3, they all competed in the super polls. And what we find was that the forecasters who were identified in prediction markets did about as well as those who were identified in prediction polls, even though the market folks had to switch structure. They learned pretty fast, and at the end, they produced forecasts of similar accuracy. The only folks who did better were those who were already super forecasters in the previous year. On the other hand, at the sub-elite rank, so if you don't make it to super forecaster and you keep forecasting in the same condition year after year, ideally we want systems that produce reliable rankings. So in year 1, the ranking is ABC. You want something that resembles ABC. You don't want the ranking to switch completely from year to year. And here we find that in that group, prediction polls did produce more reliable rankings based on Brier score relative to the rankings that prediction markets produced based on earnings. And so that means that in our interpretation, prediction polls produce more reliable signal of who is skilled. Finally, to put the findings in context, our question 1 was between LMSR and CTA markets. LMSR outperformed, especially on questions that attracted little attention of few traders. The small elite crowds of super forecasters produced more accurate forecasts, even though they were about 2.5 times smaller than the larger crowds. And on the other hand, team polls and LMSR markets were about on par in terms of accuracy. Relative to prediction polls, market qualified forecasters of equal skill, but produce less reliable rankings at the sub-elite level. So if you want to maximize accuracy and reduce information leakage, there are 2 things you can do. One, for sure, that helps in both ways is to use smaller elites or pre-selected crowds. And if you only care about accuracy, either prediction polling or the LMSR market structure would produce similar results. I think we have time probably for a question or 2.
We have time for questions.
So if I understand correctly, you are selecting the elites by ranking them based on their score. But from a theoretical point of view, if you are using a proper scoring rule and you apply a ranking after that, this proper scoring rule is not proper anymore. Do you have anything to say about this?
Yeah, so there's work on forecasting competition where instead of just providing a ranking, you only pay the top forecaster, the top few forecaster. Grushka, Cocaine, and Casey Lichtendahl have done work on that. What they show is that while it's not proper, it might incentivize forecasters to overweight their private signal, which might make them less accurate individually, but it might either help or be neutral to crowd performance. And so we were okay with that in this respect. Mm-hmm.
Like one of the benefits, at least in theory, of a prediction market is the information leakage, and like maybe learn from what other people are doing and improve. So I guess, are you saying like that in practice for markets or in your situations, that extra bit of learning from each other didn't seem to help?
Yeah, so that,
Didn't seem to matter.
so that extra bit of learning helped LMSR markets bring them up to a level with team prediction polls. In teams, people will learn from each other within a team, but it didn't help markets outperform, right? So there are probably factors like in a team you coordinate and you learn from each other. In a market you compete, but you still learn the price based on your peers. And so those two information structures seem to produce approximately similar accuracy in a larger or in a smaller crowd.